What if I told you everything your simulation shows could still be wrong? You trust the software. You see the clean toolpath. No collisions. No warnings. Perfect cut. But the moment the tool touches real metal, collision symbol snap. The tool breaks. The part is ruined. And your confidence? Gone. So the question is, can you really trust simulation? Or is reality playing a different game? Let's break this down. In simulation, everything looks perfect. Heavy check mark smooth tool motion. Heavy check mark ideal cutting conditions. Heavy check mark zero unexpected forces. But here's the truth nobody tells you, simulation is based on assumptions. It assumes your material is consistent. Your tool is perfectly sharp. Your machine is 100% rigid. Your setup has zero vibration. Sounds perfect, right? But in the real world, warning sign material hardness varies. Warning sign tools wear out. Warning sign machines vibrate. Warning sign heat builds up fast. And that's where things start to go wrong. If you've ever done machining, you've probably experienced this. You run the simulation, everything looks safe, so you hit cycle start with full confidence. The machine begins, the tool engages, and suddenly, grimacing face the sound changes. Fire heat starts building. Chart with downward trend, the load spikes, and before you can react, collision symbol tool failure. You pause and think, wait, simulation didn't show this. Exactly. Because simulation doesn't feel cutting resistance. Chip evacuation issues. Micro vibrations. Thermal expansion. It's like watching a car race in a video game versus actually driving at 200 kilometers per hour on a real track. So we decided to test it. Same setup. Same toolpath. Same parameters. Computer monitor first, simulation, smooth cut. No overload. Perfect finish predicted. Looks flawless. Now real machining. Hammer and wrench tool enters the material. At first, everything seems fine. Then slowly, you notice, chips not clearing properly. Slight vibration. Heat increasing. And then, collision symbol crack. The tool breaks mid-cut. Not at the start, not in simulation, but exactly where real-world conditions stacked up. That's the shocking part. White right pointing backhand index simulation didn't fail. White right pointing backhand index reality exposed the missing variables. Here's what this teaches us. Simulation is a guide, not the truth. It helps you. Heavy check mark visualize toolpaths. Heavy check mark avoid collisions. Heavy check mark plan operations. But it cannot replace cross mark experience. Cross mark machine feedback. Cross mark real cutting conditions. The smartest machinists don't rely only on simulation. They combine gear data plus experience. Gear software plus sound. Gear prediction plus observation. Because in machining, white right pointing backhand index, the real test begins when the tool hits the metal. So how do you avoid this? Here's the smart approach. White heavy check mark start conservative, lower feed and RPM. White heavy check mark monitor sound and vibration. White heavy check mark check chip formation. White heavy check mark adjust based on real-time feedback. White heavy check mark never trust simulation blindly. Think of simulation as a map, but remember, you still have to drive the road. Now I want to ask you, have you ever trusted a simulation and got a completely different result in real machining? Speech balloon, comment your experience below. And if you want more real-world CNC insights, tests, and experiments, Heavy black heart like this video. Bell subscribe for more. Public address loudspeaker share it with someone who trusts simulation too much. Because sometimes white right pointing backhand index the biggest lessons come not from software but from broken tools. Watch his hands. Slow. Steady. Confident. He adjusts the hand wheels. Not randomly, not quickly, but with experience built over time. The metal workpiece sits inside the vise. Cold. Rigid. Waiting. He aligns it perfectly. Tightens it down. That moment, when the metal is locked in place, is where preparation meets execution. The workshop around him is bright. Natural light enters softly through the windows. Everything feels controlled. Clean. Precise. No chaos. No noise beyond the machine. Just a man and a process he fully understands. Look closer at the textures. The polished metal reflects light subtly. The machine's painted surface carries years of use. Every edge, every surface, real. This is not animation. This is not simulation. This is reality. The tool moves with intention. The machine responds with power. There's a connection here between human control and mechanical force. And that connection? It's built on skill. People often think machines do the work. But machines don't think. They don't judge. They don't adapt. The machinist does. He understands feed rates. He understands pressure. He understands how metal behaves under force. That calm focus you see. It's not just concentration. It's awareness. Because he knows if something feels off, even slightly, it probably is. Sit down. And in this moment, when the metal is locked in place, is where preparation meets execution. The workshop around him is bright. Natural light enters softly through the windows. Everything feels controlled. Clean. Precise. No chaos. No noise beyond the machine. Just a man and a process he fully understands. So next time you see a machine in action, don't just watch the tool, watch the hands behind it. Because that's where the real skill lies. White right pointing backhand index. If you respect precision like this, drop a like. Heavy black heart. Comment what you noticed. Speech balloon. And subscribe for more real machining moments. Bell.